In this video, we're going to talk about how to simplify, add, subtract, multiply, divide, and rationalize radical expressions. So let's talk about what a radical is. So let's say I gave you the radical x. Okay, well let's kind of dissect this. This shape that I'm kind of outlining with my red marker is the actual radical. A lot of students will automatically just call this a square root, but this is actually called a radical. The radical itself tells you if you're going to do a square root, a cube root, or any other root. That depends on whatever your number is that sits right here. The number that sits here, for instance, for this question, is considered a 2. We don't always write it, but it's understood to be a 2. This is called your index. Underneath your radical, this information is an x. Okay, well this x could be any other kind of expression. It could be 3x plus 2, it could be x squared minus, or x squared y, it could be a bunch of different things. But we call it, in reference to your radical, a radicand. This radicand is going to help us with actually simplifying your radical based on what your index is. So all of these things kind of connect. So let's go ahead and simplify, like you did back in Algebra 1, the square root of 18. I have my own special way of simplifying this, which I'm going to use. It's up to you guys if you choose to use it. If you like what your teacher did when you were back in Algebra 1, you are more than welcome to do that. However, I like to simplify it this way. So on my page, I'm going to go ahead and write out 18. We're going to split up 18 into nothing but prime numbers. Prime means it's only divisible by 1 and itself. So let me see. 18 I can break into 9 and 2. 2 is prime. And 9 I can break into 3 and 3, which are also both prime. Okay, so I'm going to rewrite my square root of 18 as 3 times 3 times 2. I always ask my students, what is the index on this radical? Where the index on this radical is a 2. That's a number that sits on that radical. What makes my method so easy to use is this little index tells you how many of these numbers you can group together. In order to group the numbers together, they must be the same. So for instance, for this question, your index is 2. So if you can find 2 of the exact same number, you can group them together, like I have here with the 3's. As you help these 3's escape from this little radical prison, this is the square root portion. In order to take the square root, which is what your index is, you can only help one of those numbers in that group escape. So if I was to take, for instance, the square root of 9, hopefully you know that that's 3. Well, if I was to use my little grouping method, if I was to take both of these numbers and help them escape, only one would make it out. So only one of the 3's would make it out, and underneath your radical, you'd still have a 2. This is your simplified radical. What this does for students is it helps them see visually how to actually simplify your radical without having to memorize things. What this method does is it prevents you from memorizing a bunch of numbers. Let's look at another question. Let's look at example 4. For example 4, we have the square root of 21. Okay, let's take 21 and split it into nothing but prime numbers. Okay, well just my luck, 7 is prime and so is 3. So let's go ahead and rewrite this radical as 7 times 3 and try to simplify it. Okay, well let me think. I need to look at my index here. My index on my radical is a 2. Okay, well let's look at this. In order to group both of these together, they need to be the same. Are both of those numbers the same? They're not. Since both of those numbers are not the same, that means that the square root of 21 can't be simplified. It already is. So I'm just going to put simplified. It's already simplified. On test or quizzes, you can either write simplified or you could rewrite the square root of 21, but let's be honest, most of the time I write my answers, I'm probably just going to put it as just simplified, just to make it easy. Okay, well that's pretty much it for simplifying. So let's talk about how to add and subtract radicals. This item over here is your steps. So these steps are going to help you with going ahead to actually simplify it and making sure your answer is correct. So the first thing you're going to do is you're actually going to simplify all of your radicals. Once you do that, you're going to identify the radicals with the same index and the same radicand. That means they have the same little number that sits on your radical and the same number underneath your radical, or the same variable underneath your radical. Only those are the ones that can be combined. The common radicals, for whatever those are, you're going to be able to add and subtract the coefficients, which are the numbers in front, and you're going to keep the common radical the same. So this is very similar to if I had 3x plus 4x. Okay, well with problems like this, yeah, you can combine them. So this is kind of looking at the x's you can combine because they're the same. So it's kind of similar as the same index and the same radicand. All you would do is you would just add or subtract your coefficients. So you would get here 7x. That's all you would have to do. We're doing the same process here, but we're just doing this in radicals. That's all. So let's start with the first one. First thing I'm going to do is I'm going to take the square root of 27 and the square root of 12 because they are both not the same. Let's go ahead and simplify 27. Okay, let me break this into nothing but prime numbers. We're going to multiply 9 and 3 to give me 27. 3 is prime. 9 I can break into 3 and 3. Both of these 3's are prime. So underneath my space, I'm going to write 3 times 3 times 3. Okay, well let's think. The index on this radical is a 2. I don't see a number, so you can safely assume that the index is a 2. Okay, well I'm just going to make one group of 2 3's. I know that there's 3 total, but let's just make one group of 2 3's and help it escape. Only one of those 3's will make it out of that radical prison. So we're going to rewrite this as 3 square root of 3. This 3 made it out. This 3 is still under your radical. So over here to the side, I'm going to rewrite 3 square root of 27. And instead of the square root of 27, we're going to put 3 square root 3. All right, let's do the same thing for the next one. Square root of 12. Okay, for square root of 12, we're going to break this into, I don't know, let's do 6 and 2. 2 is prime. 6 I can break into 3 and 2. Notice, guys, whenever I'm simplifying my tree, like I have over here, I always start with one side and then I work on the other. I work on one whole side all at the same time. So I'm starting for now on the right-hand side because it's really just prime numbers on the right, but I could also start on the left-hand side as well. So let me rewrite my radical. 2 times 2 times 3. If you multiply all of those numbers, you will get 12. The index on this radical is a 2. So if I group both of these 2's together and help them escape, only one will make it out. So my simplified radical is going to turn into 2 square root 3. Okay, well this is a little different. It said before once you have both of your index and radicands are the same, so your index for both of these are the same, your radicands are both the same, it says you're just supposed to add and subtract. It wasn't accounting for these parentheses. Well, those parentheses mean that you're going to have to multiply really quick. So we're going to multiply 3 times 3, which is 9 square root 3, and we're going to multiply negative 2 times 2, which is negative 4 square root 3. Keep in mind, guys, I'm not distributing this 3 and this 2 to both of the radicands underneath. I'm just multiplying the number in front. Once we have that, we can just add and subtract. So I'm going to take this 9 and this 4 and just subtract. This would be my answer. I want you guys right now to take a second and look at question number 2. Okay, you're more than welcome to start it off. But I'm also going to go through it with you. So if you haven't paused the video and you want to solve it on your own, pause it now. Alright, so let's start this off. We have 54, we have 2, and over here to the side, we have negative 16. Alright, let's break up the first one. 54, I can break this into 2 and 27. 2 is prime. 27 I can break into 9 and 3. And 9 I can break into 3 and 3. So I have the cube root. Keep in mind this is a cube root of 3 times 3 times 3 times 2. Alright, well this one's a little different. Now that I have the cube root, I need to make sure that I actually group these now into groups of 3. This index is the most important thing on your radical. This tells you how many things can be grouped together. So I'm going to group 3 3's together, all 3 of them. As I help them escape from this little radical prison, the same rule applies like we just did in question 1 above. Only one of those numbers can make it out. So I'm going to cross off this one, and I'm going to cross off this one. Only one of those 3's will make it out. So the cube root of 3 times 3 times 3 is just 3. And I'm still going to have the cube root of 2 underneath. This 2 stayed, this 3 escaped. The other 2, they're just gone. So up here at the top, let me replace the cube root of 54 with, we're going to have 3 parentheses. In that parentheses, we're going to put 3 times the cube root of 2. All right, let's look at the next one. Okay, for 2, let me split this up. I have 1 and 2 as my multiples. Wait, is that it? Only 1 and 2? Well, those are both prime. I could rewrite this, but I don't need to. Is there any way that I could group 3 things together under here? I mean, sure, I could do 1 times 1 times 1, but it's not going to change your answer. So for this question, the cube root of 2, it's already simplified. So what I'm going to do over here is I'm going to rewrite this as minus 2 cube root of 2, because I can't simplify it any further. I still want to try to see if it could be added or subtracted to anything, but I can't simplify it any further. Let's go ahead and do the last one, cube root of negative 16. Some of you guys are probably getting antsy like, uh-oh, I thought we can't simplify something that has a negative under a radical. That's true if you had, for instance, the square root of 16, because an even root cannot take a negative radicand. It can't do it. With a odd radical, odd index, you can actually simplify this. So what I want you guys to remember, and I definitely want you to write this on top, is that the cube root of negative 1 equals negative 1. The cube root of negative 1 equals negative 1. So what we can do is we can rewrite this as negative 1 times 16. Negative 1 times 16 will give you negative 16, and the cube root of negative 1 will equal negative 1. So I'm going to go ahead and circle negative 1 as a prime number. 16 I can break up into prime numbers as well. 4 times 4. This 4 will split into 2 and 2. This 4 will be split into 2 and 2. So let me rewrite what I have. For the cube root of negative 16, we have the cube root of negative 1 times 4 2's. All right, well, let me remember. I just told you guys, wait, what was the cube root of negative 1? Negative 1. That's a rule. The cube root of negative 1 is just negative 1. So I'm going to take out a negative 1, and let me see, I can group 3 2's together. Not all 4, but I can group 3 of them together. Only 1 2 will make it out. Every additional number you take out, you're just going to multiply with the prior number. So you're just going to multiply them. I'm going to keep the cube root of, unfortunately there's 1 2 left over, so I'm going to stick him under here. All you need to do, guys, is just multiply both of these two numbers. So negative 2 cube root of 2. This would be your answer. So up here next to that 7, I'm going to go ahead and put a parentheses behind this and stick in negative 2 cube root of 2. This is what I need to simplify. So just like we did before, we're going to multiply 3 times 3, which is 9, cube root of 2. The second term can't be simplified. And then we're going to multiply 7 times negative 2, which is negative 14, cube root of 2. All we're going to do now, guys, is add and subtract. So 9 minus 2 minus 14. 9 minus 2 minus 14 is going to give you negative 7, cube root of 2. And double check, guys, each of the index for each of these radicals are the same. Each radicand is the same. That is the only reason why I was just able to add and subtract the coefficients. I could do more questions, guys, but it's up to you to practice. This rule here for negative 16 about that negative 1, I would do that for every question you have that has some kind of negative under your cube root. So rewrite it as negative 1 times whatever the number is, positive, and then just simplify it from there. All right, let's go ahead and look at the next page. We're going to go ahead and look at multiplying. So with multiplying, here are your steps. Okay, with the steps, you're going to multiply your coefficients, and then you're going to use the product rule to go ahead and simplify it. What the product rule states is you're going to take whatever your radicands are, so in this case A and B, and you're just going to multiply them. That's how you use the multiplying radicals. Once you multiply and you do this whole first step, then you're going to simplify. So unlike adding and subtracting, simplifying waits until the end. You can simplify first, guys, but I'm telling you now, it's unnecessary. I'm speaking from experience. Let's go ahead and look at question 5. So for question 5, we're going to go ahead and multiply this one out first. So it first said to multiply. Okay, so let's go ahead and do that straight across. We're going to multiply the coefficients. In front of this radical, there's no number, so we're going to put a 1. In front of this radical, we have a 5. Well, 1 times 5 is just 5. Next, we're going to multiply the radicands underneath. So 6 times 8 is going to give me 48. And x to the 4th power and x to the 5th power, when you multiply the same base, you add the exponents. So 4 plus 5 is going to give you x to the 9th power. What we need to simplify is 48x to the 9th power. Okay, so let me simplify 48. 48 is multiples of 4 and 12. 4 you can break into 2 and 2. 12 you can break into 4 and 3. 3 is prime. 4 I can break into 2 and 2. So let me check. All of this is simplified. Good. All of this is simplified. Good. X to the 9th power. Think about it, guys. What does x to the 9th power mean? X to the 9th power means you literally have 9 x's. You're just multiplying them. So let me rewrite what I have. 2 times 2 times 2 times 2 times 3. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. The index on this radical is a 2. If I can make a group of 2 of the same variable or number, I can help it escape. So in this group of 2, I can help it escape. Only one of the 2's will make it out. I can make one group of 2 here. As I make this group of 2, only one of the 2's will be able to escape. So I'm timesing another 2. This 3, I'm sorry, it's stuck. I can't multiply it with anything. I can't help it escape. For the x's, think about it. How many groups of the x's can I make? I can make 1, 2, 3, 4 groups of the x's. They each have a partner. Only one of each of those partners in each of those groups will make it out. So that means I'll have 1, 2, 3, 4 x's that are able to escape. X to the 4th power. That unfortunately leaves one more x left over. So underneath my radical, I still have a 3 and an x. All I would request you guys do is just multiply 2 times that x to the 4th power, which will turn into 4x to the 4th power, square root of 3x. So let's go ahead and add that in up here. So we're going to rewrite this as 5 parentheses. In that parentheses, we're going to put 4x to the 4th power, square root of 3x. All I need to do now is just simplify. So I'm going to multiply 5 times 4, which is going to give me 20. X to the 4th power, square root of 3x. Do not multiply that 5 with the 3. Do not distribute that. This would be your answer. Right now, I want you guys to pause the video, and I want you to try question number 3. So this should be your answer. I broke down 270, so 54 times 5 is 270. M to the 8th, M to the 4th, you just add the exponents. So I'm going to go ahead and write this out. This is a 12, by the way. 12. And I went ahead and I actually wrote out all of the multiples for 270. So I have all of them written here underneath my radical, and all I did from here was I just grouped them into groups of 3. So I have one group of 3 for my 3's, and I had 4 groups for my m's. From each of those groups, I only took out one of their respective number or variable. I will mention, guys, there is a shortcut to simplifying m to the 12th power in any variable raised to any exponent, but I'm not going to tell you what that is. I want you, as you go through more questions, to discover what that trick is. Once you learn the trick, you can always use it on my tests and quizzes. However, if you don't know what the trick is, I don't want to tell you because you'll automatically go to that shortcut instead of doing the process. So I will say, for those of you guys who figured out the trick for how to simplify the cube root of m to the 12th power, continue to use it. This is your answer. All right, we're going to go ahead and flip to the next page really quick. And we're going to look at questions 18 and 20. Even though I'm not going to solve question 18 with you, I at least want to talk about it because I know you're going to forget what this means. This too has a specific meaning. It does not mean just distribute. What you need to do is you need to rewrite this binomial 2 times. And I already know somebody's not paying attention and they're going to forget this. Guys, when you have this squared, it means multiply the exact same binomial 2 times. When you multiply it, you're going to need to FOIL. Make sure you FOIL this. Let's look at question 20. Question 20, we're actually going to multiply. So for question 20, the first thing I'm going to do is I'm going to distribute. So we're going to make this a square root of x squared plus the square root of 2x, because you're just multiplying radicals, negative square root of 8x, and then the negative square root of 16. Well, let's first see if I can combine anything or maybe simplify anything. Well, I will tell you the square root of x squared and the square root of 16 can simplify. Square root of x squared is just x. Square root of 16 is just 4. So I now need to see, can I combine both of these here? I did have one student earlier tell me that the square root of 6x would be your answer. Let's look back at the other page. If you were looking at adding and subtracting radicals, can you do that when your radicands aren't the same? Well, it literally says this on the other page. If you're trying to add and subtract radicals, where am I? There we are. If we're trying to add and subtract radicals, they need to have the same index and the same radicand. You can only combine it when it's the same. If it's not the same, you cannot combine it. So for this question here, I can't combine the two guys in the middle. However, I can simplify this guy to make it to where they're both the same. So over here to the side, let me actually rewrite this. We're going to have the square root of 8x. 8 I can break into 4 and 2, and 4 breaks into 2 and 2. So I can rewrite this as 2 times 2 times 2 times x. Okay, well let me think. If I was actually going to try to take the index, which is 2, and group things together, I can make one group of 2. Which means if I simplify this radical, it would turn into 2 square root of 2x. Let me rewrite what I have. In that parentheses, I was able to simplify it to 2 square root of 2x. This is extremely important. This radicand matches this radicand. The index, which is 2, matches this index. Because that's the same, I can now simplify. So we're going to take both of these terms in the middle and combine. Square root of 2x minus 2 square root of 2x is just the square root of 2x. Technically it's a 1 in front, but guys, y'all already know you don't need to have that 1. This would be your answer. You don't really need to write this in any descending order. This would be your answer. That's it. I'm going to look at one question below for dividing, and then we're going to move on to the next page to rationalize. Okay, so here are our steps for dividing. With your steps, you're going to divide the coefficients, and then you're going to use the quotient rule to simplify. Similarly to the product rule on the other page, the quotient rule just states that if they both have the same index, you're going to take their radicands and you're going to divide them, whatever those radicands are. And again, as a last step, you're going to simplify the resulting radical. So let's look at question number 3. Okay, question number 3 doesn't have any coefficients, but if we did have coefficients, we would be able to divide them. Since we don't, we're going to go ahead and continue to simplify. Okay, so let me see. I'm going to rewrite this as a big square root because the index here is 2. The index here is 2. I can rewrite this as x to the 3rd power, y to the 9th, over x squared, y to the 5th. Think back to Algebra 1. When you have bases that are the same and you're having the exponent rules, what would you do with these exponents? You would have to subtract them. So this is going to turn into x to the 1st power, because 3 minus 2 is 1, and then y to the 4th power. All of this is now over 1. There's no more denominator. So you can rewrite this as square root of x, y to the 4th. From here, some students would just say, oh, this is my final answer, Ms. Tapia. No, you're not done. Square root of x is pretty much just the square root of x. But the square root of y to the 4th, that means that you have 1, 2, 3, 4 y's. Okay, well, if the index on this is 2, you can help these guys escape. So that means if I was to simplify the square root of y to the 4th power, that would just be y squared. So let me write out my final answer. This is going to be y squared square root of x. We're going to look at 2 questions on the last page. Question number 2. For question number 2, this asked you in the directions to rationalize. Okay, so let's think about what it means to rationalize. In order to rationalize something, we need to get rid of this radical. Technically, it's okay, with what you have, But when it literally says for you to rationalize, it's telling the reader, get rid of your radical. So what we're going to do is we're going to multiply the numerator and denominator by the square root of 5. That's the only thing that's the issue. The 2 isn't the problem. That's fine. It's the 5 that's the issue. So we're going to go ahead and multiply it. So in the numerator, we're going to have 3 square root of 5 over, and the denominator, we're going to have 2 square root of 25, because 5 times 5 is 25. Some students will tell me, oh, Ms. Tapia, both of these numbers simplify. Oh, you're absolutely right, but you're going to end up right back at the original problem. That's not what I want. Can you simplify the square root of 5? No. You can simplify the square root of 25, though. The square root of 25, oh my gosh, it's the worst square root I've ever made. Square root of 5 over 2 times 5, because the square root of 25 is just 5. Once you have that, a lot of students will tell me, oh, Ms. Tapia, we can cancel these. No, you can't. It has to be under a radical if you can cancel that. So instead, we're just going to leave our answer as 3 square root 5 over 10. This would be your answer. There's one last question we're going to look at, and that's going to be question number 4 over here. For question 4, I'll tell you now, if you try to multiply this by the square root of 2 over the square root of 2, you're doing it wrong. What do we need to do to this denominator in order to get rid of this radical? Well, let's think back to Algebra 2 earlier in the year when we were talking about quadratic functions. How do we get rid of this radical? Well, if we look back to a complex conjugate, what complex conjugates do is it literally will cancel out your radical, so you're only left with a real number. That was the whole point of us doing this. So if we were pretty much going to take our conjugate for this, like how we did for imaginary solutions, we would be able to get rid of the radical and just get a regular number. And that's what we're going to do. Even though this was talking about for complex numbers, we can do the same thing for radicals. So I'm going to make a little note here. You're going to use the conjugate. So the conjugate for this, you're literally just going to take this denominator and switch the sign. So we're going to make this 4 minus the square root of 2, 4 minus the square root of 2. In your numerator, you're just going to distribute that 4. So we're going to make this in the numerator, 4 times 4, which is 16, minus 4 square root 2. The denominator, we're going to need to FOIL. So 4 times 4 is 16. 4 times negative square root 2 is negative 4 square root 2. Square root of 2 times 4 is positive 4 square root 2. And then square root 2 times square root 2 is going to be negative square root of 4. Okay, well, let's look at it. Is there anything we can combine? Well, if you think back, we can actually combine both of these. They're the exact same radicands, exact same index. And if you notice, the coefficients are 1 positive 4, 1 negative. So these are going to cancel. So in your numerator, you have 16 minus 4 square root 2. Sorry, that can't simplify. But in the denominator, we're going to have now 16 minus, well, the square root of 4 is 2. Notice how now I have no more radical. That's what I wanted. So I'm going to simplify this just a little bit further. 16 minus 4 square root 2 over 16 minus 2 is going to give me, not 12, 14. The only other thing you might have to do is actually simplify this further. This is simplified, but the only way to simplify it further is factoring out a 4 from this numerator. So I'd factor out a 4 here and make it 4 minus the square root of 2 over 14. What that's going to allow me to do is reduce this, so that way I can make it into, let me rewrite this, we'll have 2 and 7. So we're going to rewrite this as 2 times 4 minus the square root of 2 over 7. So I factored out too much, but it's okay. I'll just redistribute it. So we're just going to make that 8 minus 2 square root 2 over 7. This would be your final answer. Guys, this looks intimidating and disgusting, but it's really not. It's over basic concepts we've already talked about. If you look at question number 5, I'm not going to do this one with you, but if you look at question number 5, this one explicitly is another conjugate. So if I asked you guys to write the conjugate for this denominator, what would you write it as? Hopefully, you would write it as 2 minus 2 square root of 7. And then, of course, for this one, unfortunately, you're going to have to FOIL the numerator and denominator. So FOIL all of this, and then FOIL all of this. But it's doable. If you have any questions, guys, make sure you reach out and let me know.